is a curvature, is a rectifiable. Okay, that's a rectifiable curve. Or a curve. It's a rectifiable curve. Okay. So in other words, if I have a region which is type 1 and type 2 both, and its curve is rectifiable, I'm going to call it a green region. जी, आप क्या कह रहे हैं?
सर बाउंड्री क्या है वो सीधी लाइन नहीं हो सकती?
सीधी, सिर्फ सीधी लाइन।
मतलब सीधी लाइन इस तरह रेक्टेंगल होती है।
हाँ बिल्कुल,
वो भी ग्रीन रीजन।
बिल्कुल ग्रीन रीजन होगा, because then the boundary of the curve is going to be the concatenation of the four lines actually. Any one of the line of the rectangle as this one. Okay? So here's a green theorem. Here's a green theorem. So imagine I have a vector field F that has two scalar fields as its components, okay, P and Q. F be a smooth vector field, okay, defined on a Green's region, ठीक है, S. Then, if you want to integrate, or you want to compute the classical line integral of this F. So what would be the classical line integral of this F? So it's going to be P dx plus Q dy. Okay, over the boundary of the S, where S is the the boundary of the green region. Then you can compute it as double integrating. Okay, what is the outcome of the first function? Now, S is a Fubini type 2 and type 1 both. So it's type 2 and type 1 both. So since S is Fubini type 1, so what would be the outcome of this first part of the integral? So it's going to be
minus
this. And what would be the outcome of this? It's going to be this. So I can write this as a double integral over the entire region as say partial Q by, okay, partial X minus partial P by partial Y and dx. ठीक है? dx. This is green theorem. A precise description, and we already have proved it. So I hope that you can see that we have already proved it. Now, what are some interpretations and uses of the green theorem? First of all, so if I have a vector field F, so this is nothing, this is just I am computing, if you see, this is nothing, this is just I am computing the integral of F over the boundary of S.
Yes.
This is just an alternate way of writing it. So F is a vector field, so it is representing that something is flowing in this green region actually. So it's like the balls that we saw last time, they are going all over in the green region. So here is a line integral for you to evaluate. Okay? So evaluate this vector fields along the curve C. So it's y square minus sine e to the x plus xy dx minus x power 4 secant hyperbolic power 4 y minus 2xy dy. Yeah, look, Papa. So think about it. And the curve C, huh? This is both of them, you know. I mean, even if you turn it into, for example, the Riemann integral from A to B in the terms of, say, in the terms of t, still you have to deal with this monster. So sine of e to the x. What would be the integral of sine of e to the x? So you can numerically compute it. You can't compute it. So there's no hope of computing it exactly actually. Okay? So you're going to see what miracle happens actually. And the C is this. So C is a rectangle, is a unit square. So it's a unit square, okay, with, okay, the vertices 0, 0, 1, 0, 1, 1, and 0, 1. So this is the rectangle on which you have to integrate. So if you want to integrate this as it is onto this curve, you have to compute the 4 integrals. Idhar alag, idhar alag, idhar alag, idhar alag. Okay? But now, does this satisfy the condition of Green theorem?
Yes, sir.
So if this is smooth, is there anything that can create trouble? There's nothing that can create trouble. Is this a green region? Yes, it's Fubini 1 and Fubini type 2 both actually. So we are very happy. So let's apply the Green theorem. So if I'm going to apply the Green theorem, this would be the integral, of something over dx dy. While I know that x goes between 0 to 1 and y goes between 0 to 1. Okay? And then I need to what? So this is like my p and this is like my q. Okay? So the coefficient of dx is p. So what would be the derivative of this with respect to the x actually? क्या हो जाएगा? So it's going to be 4x cubed plus 0,
Yes.
okay, and
Minus 2y.
minus 2, right, minus. So what would be this? Am I doing something silly? Why this is really so p dx and q dy. So p dx and q dy is the q with respect to the x and p with respect to the y. जी, तो आप क्या कह रहे हैं? What do you call it?
सर ये वहाँ पे प्लस था ना, p dx plus q dy, यहाँ पर p minus q dy, ये बीच में माइनस है ना, तो ये माइनस देंगे ना.
Okay, so I can either put plus here and minus everywhere. So this could be one of the way to deal with it. Okay, so it's going to be minus 4x cubed and plus 2y. So what would be this now? So differentiate it with respect to x, with respect to y. So this would be 2y 0 plus what? X. Yeah. So this crazy integral turned into something really simple. Okay. I can easily control this integral then. So thanks to the Green's theorem. Okay. Hats off to the Green's theorem. ठीक है जी. भाई तक जी बाप. रेस्ट करते हैं, सफल करो. y हमारा विधा तो जो है इससे डिफरेंट है.
आपने x पावर 4 लिखा है यहाँ पे.
मैं लोगों की टक्कर Correct. I mean, if it is even power 4, still it makes sense.
Yes, sir.
So it's x square actually. So that over 2x is it gets just even more simpler actually. So minus 2x plus x and becomes x actually. So still it does work actually. ठीक है जी. आखिरी 5 मिनट. Just consequence of it, nothing new. ठीक है? Another last consequence of it. So I would like to invite you to apply the Green's theorem to this vector field. So that take this vector field particularly. Okay? What vector field? This vector field. So take P to be minus say y upon 2 and take Q to be x over 2. Okay? And apply your Green theorem. So if you can apply Green theorem and imagine that you have S is some Green region. So what would be the Green theorem? So what would be this side? This side is going to be, I can take this 1/2 out. So it's going to be minus y dx plus x dy, and this is equal to what would be the other side? The region S. So what would be the, so differentiate this with respect to S, so this is going to be 1, okay, and this would be minus 1, so it's going to be plus 1 and dx dy. Okay. So what does this show? So this is the 2 times of, is it? Okay, so this is going to be 1/2 and 1/2 actually.
Yes.
Not the just because we have 1/2 there. So this side is going to be the integrating double integral of dx dy over the entire region S. So can I say this is A of the S, the area of the S actually. So if you want to compute the area of a green region, just compute this line integral. Y dx plus x dy on its boundary. Okay? And this is called the green area formula. Okay? So in other words, if you have a green region,
PDX plus QD by integration है वहाँ पर area of green region.
yes. So if you have to, for example, choose if you have a particular given curve and you are interested in computing, for example, its area like a circle or an ellipse or something like that, just compute this line integral and you're going to get the area. What would be the sample example? सिर्फ बता रहा हूँ, ठीक है? करना खुद कैलकुलेट, So ellipse की क्या होती है equation? So what is the parameterization for ellipse? X of t is a cos t.
Yes, sir.
And y of t is
B side.
b sin t, where the t goes between 0 to
2 pi.
pi actually. ठीक है? So can I compute the area of this? कर दूँगा compute?
So we are given y and x.
So you need to do out 1/2 of, if I just substitute values. So you are integrating with respect to t, so you have to integrate 0 to 2 pi. So what is your y? Y is minus b sin t. What is dx? So x is a cos t, so it's going to be minus a sin t dt plus, you're going to take a cos t times dy. In other words, it will be b
Cos t.
cos t and dt. So you can already see that this is ab sine square plus ab cos square. So you can bring this ab out. You have a 0 to 2 pi, and you want to integrate say dt. So it's going to be what? Pi ab. And this is really the area of ellipses. It's really the area of ellipses. And circle is a particular case of the ellipse where the a and b are equal. So therefore you have a pi r square actually. Isn't it?
Yes.
Good luck.
Okay.
ठीक है? तकरीबन चैप्टर पूरा किया। ठीक है, so
Sir.
you will upload the notes.